When my team and I went to the zoo, we all noticed this, and when we closed our eyes, we felt this. These are all patterns, and these repeated patterns becomes written, and nature is nothing if not rhythmic, and its rhythms are many and vary. This is the rhythm of life. The 7th chapter of the book Nature's Number.
Leland Stanford, a railroad magnate, wagered $25,000 in the 1870s that a shooting horse would eventually have all 4 feet entirely off the ground. Edward Muybridge took photographs of several horse faces on the gate to settle the wager. The horse blue chalk mask will be captured by a line of cameras with tripwires.
Additionally, it is the scientific study of gaits, a methodical investigation of animal locomotion, and more precisely a study of human motion employing the eye and brain of circles in conjunction with measuring equipment for monitoring body movements. Furthermore, a section of mathematical biology called Biology of Body Mechanics and Muscular Activity raised questions.
To learn more about the different rhythmic patterns that appear in large animal populations, as well as to understand how and why animals move the way they do. Although biological interactions between individual animals and communities of animals are highly varied, one example is the synchronized flashing of some species of firefly.
The message of this chapter is that the same fundamental mathematical idea may be applied to a wide range of situations, and that there is an underlying mathematical unity. Nature honors this unity and effectively utilizes it. Therefore, one of the mathematical ideas we are discussing.
There is an underlying mathematical unity, and one of the messages of this chapter is that the same general mathematical concept can apply on many different levels and to many different things.
Respects this unity and effectively utilizes it. Therefore, one of the mathematical ideas we're discussing is the application of the escalation principle to biology.
Why do home systems escalate, and why does a caged tiger repeat its motion on an escalator? A unit whose innate dynamic compels it to repeat the same cycle of behavior over and over again is the outcome of combining two
Construct first, it feels restless and does not wish to sit still. Second, it is confined within the cage and cannot simply disappear over the nearest hill. The simplest thing you can do when you have to move,
but can escape altogether, is to oscillate. Of course, there is nothing that forces the oscillation to be a regular wisdom, but a tiger is free to follow an irregular path around the cage.
The simplest option, and therefore the most likely to arise in both mathematics and in natures, is to find some series of motion that works and it repeats over and over again.
A system that has a steady state may lose it and start to wobble regularly in 1942. The German mathematician Eberhard Hoff discovered a general mathematical condition that guarantees such behavior in his honor. Many escalations develop out of steady states as conditions change.
This scenario is known as Hoff bifurcation. The word bifurcation is used in a particular mental image of what is happening in which the periodic escalation grew off from the original steady state like a ripple. And upon growing out from itself, the physical interpretation of this mental picture is that the oscillations are very small and suddenly become larger.
the speed which they grow is unimportant here. There are two biological visible mathematically similar oscillations that could be entangled in locomotion. One is the oscillators of an animal's limb can be thought as a mechanical systems within assemblies of worn bones revolving at the joints pulled this way and that by contracting muscles.
Second is the main oscillator of the creature's nervous system, the neural circuitry that causes the rhythmic electrical signals that stimulates and controls the limbs. A tree with a height of 40 feet that has fireflies on every leaf and has a perfect unison of them flashing light every 3 times in 2 seconds.
The study of Renato Aurelio and Stephen Stogats explained the reason why their flashes are in perfect synchronization.
Synchrony is a role for mathematical models, and that every firefly interplay a tree with a height of 40 feet that has fireflies on every leaf and has a perfect unison of them.
Flashing light every 3 times in 2 seconds. The study of Renato Aurelio and Stephen Stogats explained the reason why their flashes are in perfect synchronization.
And can be analyzed as each insulator fully affects other in the same manner.
It's no doubt living things on Earth has its own unique. We get to appreciate every detail of the movement, learning that this can be applied in mathematics. Reason that can be seen in the surroundings, which can amazingly be applied in mathematics.